Hello, this is Math 2134 coming to you from the College of DuPage during the fall of 2020, and this lecture is entitled Pre-Calculus Review 2. Quotients of polynomials are called rational expressions, and when you have rational expressions, we can simplify these by canceling common factors. So you see that x plus 2 times x minus 3 over x minus 2 times x minus 3, we can cancel the common factors and simplify this, provided that x does not equal 2 or 3, which is what's required for this to make sense, canceling the common factors. An algebraic fraction is simplified, or is put in lowest terms, when the numerator and denominator contain no common factors other than plus or minus 1, and the fraction contains no negative exponents. So here are two examples for you to do. Please give these a go. Let's see how you did. So on the first one, you should have factored and canceled out the common factor of x plus 3, and resulting in x minus 1 over x plus 1. In the second one, there are common factors of x squared plus 1, the whole quantity. So we factor that out of the numerator, and we cancel it into the denominator, and we simplify the numerator, and we get this as our final answer. When you multiply numerator times numerator and denominator times denominator, just like you did before. And when you divide, you invert the divisor and multiply. And here's some examples you should look at and make sure that you understand. So here's another problem for you to do. This is example 2. Give it a go, please. Let's see how you did. So here we completely factor numerator and denominator, and we realize that there are common factors that can be canceled when we factor everything completely. So we cancel the common factors of x plus 2 and x minus 4 to get this as our simplified answer. Now, when we add fractions with the same denominator, we just add the numerators over that denominator, and similarly when we subtract. And so that's what we do. But we can only do this with equal denominators, so sometimes we have to get the common denominator. And to find a common denominator, it works by finding the least common denominator of the rational expressions. So here are an addition and subtraction problem for you to do. You know what to do. Let's see how you did. So in part A, what happens is the common denominator is going to be the product of these two expressions. So in the first fraction, we're going to have to multiply top and bottom by x cubed plus 2. And in the second one, you're going to have to multiply top and bottom by x squared plus 1. We multiply this out and simplify it. And we do the multiplications. Then we combine like terms. And then we factor to see if anything will cancel. And this is our final answer. Here is part B. To do this, the first one you have to multiply top and bottom by x, and the next one you have to multiply top and bottom by the whole of x plus h. So realize you're multiplying by parentheses x plus h, top and bottom. So this is minus times the whole of that. Now when we distribute the minus signs, the x's will cancel out. You get minus h over x times x plus h, and so that's going to be our answer. We can also simplify this. You have two problems here. You know what to do. Let's see how you do. So here we're going to get a common denominator in our numerator, which is x plus 1. We get a common denominator in our denominator, and that is going to be x. So now we have this expression, and we simplify this a bit. So we're going to be doing the division. So what you're going to do is you're going to invert the divisor here and multiply. And we're going to be looking for if there are any common factors. Turns out there is a common factor. The x plus 2 is a common factor. So it will cancel, and this is your final answer. Here we have to write each of these negative exponents with positive exponents. So we get this as our numerator and this is our denominator. And now we have to get a common denominator in our numerator and our denominator. And so when we add them, we will get this in our numerator, this in our denominator. But you see it's this divided by this, so we invert the divisor and multiply, and we see we can cancel out a couple of common factors. We can cancel out y plus x, and we can cancel out x times y. And so at the end of the problem, we get xy over y minus x. Here's another problem for us to do. Here we're multiplying, here we're adding. You know what to do. Let's see how you did. So in part A, what happens is you're multiplying across the top and across the bottom. You get this expression, and it turns out that here nothing cancels, and that's what we get. Now notice we did, I guess, do a little bit of canceling because this is 2x squared plus 1 to the 1/2 over 2x squared plus 1 to the 1. So that's going to be the net of 1/2 in the denominator. In part B, we need a common denominator. This is going to be the common denominator. And think about this as being over 1. So here we're going to multiply top and bottom by the square root of 2x squared plus 3. So we do that, getting this and this. And when we distribute and simplify, we get this. Again, we factor our answer just to make sure that nothing cancels. When the denominator of an algebraic fraction contains sums or differences involving radicals, we may, and sometimes you have to do this, rationalize the denominator. And so often we will employ the identity that we've learned, that the square root of a plus the square root of b times the square root of a minus the square root of b is equal to a minus b. And so here I'm asking you to rationalize this denominator. That is, get rid of the radical in the denominator. You know what to do, and we'll check to see how you do in lecture 4.1.